Algebra 1 students, welcome to your notes for 9.6. Today we have the pleasure of working with the quadratic formula. The big idea is that any quadratic equation can be solved by using the quadratic formula. So here is the quadratic formula. If you are in the form of ax squared plus bx plus c, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And folks, you can solve any quadratic equation by using the quadratic formula. So if the quadratic formula always works, then why do we have the other methods? Okay, so for example, why do we know that we can factor this quadratic and get x is equal to negative 2 or negative 7, but we have to know how to use this quadratic formula? Well, folks, you're going to find some problems sometimes where you can't factor it, or you can't complete the square, or you can't take the square root of the whole thing. And in those particular situations, that is when we need to be capable of using this technique. So if you're taking your test and we tell you to use the quadratic formula and you use a different method, you are probably not going to get all of your points. In fact, I'm telling you, you're not going to get all of your points. So if we tell you to use the quadratic formula, use this method right here. Okay? All right, so we're going to use the quadratic formula to solve, and the first one is not in the correct form that we need it in. We need to move this 12 over to the left. So I'm going to simply rewrite this equation as x squared minus 8x plus 12 is equal to 0. Okay? And then I'm going to take the quadratic formula. So I'm going to actually write the entire quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to plug in each of my values into the quadratic formula. All right, so ladies and gentlemen, I did that really fast for you. So what I did was I plugged in all of my values for a, b, and c into the quadratic formula where they go. And notice that my 8 is no longer negative, okay? It's negative b means that's the opposite of b. So I changed that sign. And then what I'm going to do next is I'm going to go ahead and I'm going to solve just the stuff that's in what's called the discriminant right here. So I'm going to go really fast. So as you can see, if I take negative 4 and multiply that by 1, I would get, well, negative 4. And if I multiply that by 12, I would get 48. So then in my next step, I'm going to take x is equal to 8 plus or minus the square root. I'm going to take 64 and subtract 14, which is 16. Put that over 2. All right? And then I can actually do that. X is equal to 8 plus or minus the square root of 16 is 4 over 2. And so I'm going to kind of move to the right here. I've got x is equal to, I can divide both of those by 2, so it's going to be 4 plus or minus 2. So x is equal to either 2 or 6 in that particular case. All right, so for number 2, I've got x squared plus 6x minus 17. And so I'm going to go ahead and plug those values into my quadratic formula. I've got x is equal to negative b, so negative 6 plus or minus the square root of b squared, which is 36, minus 4 times a, which is 1, times c, which is negative 17. Let's extend that just a little bit, all over 2a, so 2 times 1. All right, and I'm going to go ahead and pause for just a second so I can quickly do some math there in the discriminant. All right, so I figured out that negative 4 times negative 17 was positive 68. Okay, so I've got negative 6 plus or minus the square root of 36 plus 68. So I'm going to go ahead and work that discriminant just a little bit more, and you guys will notice that I kind of just keep writing stuff down over here in change little pieces of it all together. Okay, so I've got negative 6 plus or minus the square root of 104 over 2. All right, so I can kind of break down that 104. All right, I can break that down into 2 times 52, and I could break that down into 2 and 26. Well, the square root of 26 doesn't really do me much good, but I can pull these 2's out here. So my next line would be x is equal to negative 6 plus or minus 2 times the square root of 26 all over 2. And then I can reduce that just a little bit. I can say x is equal to negative 3, and I'm going to reduce these 2's and these 6's on my next step. So I've got plus or minus the square root of 26. And ladies and gentlemen, that's what we call an exact answer. Again, I've told you guys before, I prefer to leave things in an exact answer instead of getting my calculator out and messing with that. It's more accurate, I haven't rounded it down, and it's less work. Okay, so number 3, I'm going to use the quadratic formula to solve. So I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is x equals all this stuff. I should have remembered to put that as well. Okay, so I'm going to go ahead and plug in everything I need. So I'm going to have x is equal to negative b, so negative 5, plus or minus the square root of b squared, which is 25, so 5 times 5 is 25, minus 4ac, so negative 4 times negative 2 times 7, all right, all over 2 times that negative 2. All right, folks, so we've got x is equal to negative 5 plus or minus the square root of 25 plus 56. All right, so x is equal to negative 5 plus or minus the square root 56 plus 25. Well, let's see, 5 plus 6 on this piece would make it 61 plus 20, which would make it 81 over negative 4. And so then my next step is I'm going to go ahead and take that 81 and take that square root. So I've got negative 5 plus or minus 9 over negative 4. So x is equal to, let's see, negative 5 minus 9, that'd be negative 14 over 4. Or negative 5 plus 9, that'd be positive 4 over a negative 4. And so if I reduce both of those by 2, it would be x is equal to a, well, let's see, this is a negative 14 over a negative 4, so that's actually going to be a positive 7 halves. And then the other one is a negative 1. 4 divided by negative 4, negative 1. All right, so for number 4, we've got 9x squared minus 30x plus 25. So I'm going to go ahead and start plugging those into my quadratic formula. So I would have x is equal to negative b, so a positive 30, plus or minus the square root of b squared, so 3 times 3 is 9, and I can put 2 zeros behind that, minus 4ac, so 9 and 25, okay, all over 2a, and 2 times 9 is what I need there. I'm going to go ahead and pause this and do a little bit of work there in that discriminant. All right, so I came up with 4 times 9 times 25, that equals 900. So I've got a 0 happening there, and that can occur. So x is going to be equal to 30 plus or minus the square root of 0, which is going to be just 0, over 18. And so I'm going to have a fraction there. If I divide both of those by 2, I would have x is equal to 15 ninths. And you'll kind of see over the next couple of slides when that might occur and what really is occurring there, where you only have one solution for x, where most of the time we were having 2 solutions for x. So here we go. Let's take a look at those. So folks, as we kind of study the quadratic formula, you might be getting to this point and kind of think that this is a little bit tedious, and it is. There's several steps involved in solving an equation using the quadratic formula, but this part's a little bit easier. We're going to take a look at the discriminant to determine how many solutions could potentially occur. And basically, when we are using the quadratic formula to find what x is equal to, we're basically figuring out what x is equal to at these 2 points right here that I'm bubbling in right here. So at these points right here, that is where we are solving and figuring out how many solutions that we occur and what those solutions are. And so for this piece of our notes, we're basically discussing how many solutions do we have. And so we kind of noticed on the last slide, when we have the discriminant equals 0, well, that's a case like this one where you have one real solution because you've got all of the junk under the square root. You know, when we're dealing with our quadratic formula, we've got a square root right there. When all of that junk in there equals 0, we have one real solution. And you guys should probably know that if we have a negative value inside of a square root, all right, that's where we have no real solutions, because when we kind of discuss that in Algebra 2, you're going to figure out that you can play with your imaginary friends, and we don't know how to do that yet. So we don't want to deal with any of our imaginaries yet, and so we just say that that's simply no real solutions. And obviously when you have a number that's greater than 0, like this one, then you're going to have two real solutions. So that's what's happening there. All right, so we're going to find out how many, find the number of real solutions. So we're going to find out how many solutions we're going to have in each of these cases here. So I'm going to have b squared, which is 25, and I need to make sure I've got my marker turned on. So 25's 5 squared minus 4 times AC, so times 3 times negative 2. So negative 4 times 3, that's negative 12. Negative 12 times negative 2 is going to be a positive 24, so I would have 25 plus 24, which is equal to 49. So this one means that I'm going to have two solutions. All right, so in number 6, we have b squared, which is 36, minus 4ac, which is 1, times 10. So I'm going to have 4 times 1, which is 4, and 4 times 10, which is negative 40. So I have 36 minus 40, and that's going to equal negative 4. All right, so that's where we would say no real solution, because that's going to be an imaginary situation. And then in number 7, we have 12 squared, which is going to be 144, and a negative times a negative is a positive, so it is positive, minus 4ac, so 4 times 1 times 36, and I believe 4 times 36 is 144, so we would have a situation where it's 144 minus 144, and that's 0, so we're going to have one solution. And folks, that wraps up your notes for section 9.6.